Okay. Next we have Scott Harmon, Vice President at Z Corp, and the title of his keynote is, "What would you make if you could make anything? The Replicator arrives." Please join me in welcoming Scott.
Thanks, Joe. Good afternoon, everyone. Thanks for taking the time. This afternoon, what I'd like to do is give you an introduction to a pretty cool technology called three-dimensional printing. And to do that, I'd like to kick off with a YouTube clip that has introduced the technology to almost 9 million people already.
David Kaplan has found a company that replicates tools, and pretty much anything else you can imagine, with a 3D copy machine.
I'm in Burlington, Massachusetts at the Z Corporation, where they've developed a new technology that's similar to those replicators you see in sci-fi movies. It's called 3D printing. I'm here to find out if they can 3D print my crescent wrench.
Now, to be honest with you, unlike in Eileen's presentation earlier, the Star Trek doodad is not the objective here. Quite frankly, a replicator or a 3D copying machine is the least interesting use of a 3D printer that has ever been invented. The point of a three-dimensional printer is to take ideas, concepts, visions, dreams, and make them into objects, into devices, tools, reality, things that affect people's lives. Now, in the interest of full disclosure, I'm pretty confident that I know less about medicine than anybody in this room. And so what I've done is I've picked a topic that I can't possibly be expected to answer. The answer to the question, what would you make if you could make anything, is entirely up to you. What I hope to do this afternoon is to basically tell you a little bit about the tool itself. So if you wanted to make anything, what would you make it with? I'll also run you through a pretty interesting array of people and what they have made with these kinds of tools in the past. And then finally, I'll give you a little bit of insight into why I think that, despite the fact that almost no one in this room has used a three-dimensional printer to date, in the future, I believe that you'll be using them relatively routinely. So let's get started. This is a three-dimensional printer. As you can see, it's about the size of an office copier. It plugs into a wall outlet. It's pretty easy to use in the office. We use them in our office. And the point is that you don't need a lab. You don't need a manufacturing environment. You can make things just about any place. It was designed that way. How does it work? Well, it starts with a CAD file, a computer-aided design file, basically a 3D diagram of just about anything. In this case, a mug. It could be a car or a toothbrush or anything else. With that, we bring the CAD file into our software, and we slice it up. Lots of itty-bitty little slices. Those of you who do medical imaging probably recognize this. This looks a lot like CT data and MRI data. It also looks a lot like my high school calculus class. Once we've got those slices, we send those slices over to the printer itself. And the printer is basically doing three things over and over and over again. The first thing it does is it spreads a very, very thin layer of powder, just a fine white powder. It then takes an inkjet printhead that lays down glue, and the glue solidifies that powder in the shape of those slices that we sent to the printer just a minute ago. At the same time, there are other printheads that are laying down color, that are mixing cyan, magenta, yellow, and black channels the exact same way your home color printer does. Once that's complete, the entire part, the build volume, lowers down and allows another layer of powder to be spread on top of it. This is what it looks like in action. The first thing you'll see is that gantry comes forward, is it's spreading the layer of powder, and now you can see that thing going back and forth, and there are print heads in there, and it's basically laying out the cross sections. It's gluing those cross sections together and then coating the outside with color. When the whole process is done, when that layer is finished, again, the build chamber will move down. Those slices are about 4 1/1000ths of an inch thick. And so they're so thin that you barely recognize them when the print is completed. And the process repeats itself. So we always get this question, okay, what is that thing really? I mean, it's not really, a mug or whatever. And the short answer is that it's a gypsum composite powder mixed with an aqueous solution of binder. And that's not very helpful at all to you. At the end of the day, it's a lot like a ceramic or a porcelain. So it's relatively strong, but it's not bendable. It doesn't have the same material properties as what a real shoe or a real mug does. But that doesn't mean that people haven't done some pretty amazing things with the technology over time. So what have people made with this? The technology actually started with engineers and designers, people who make products, everything from motorcycle motors to brake rotors. footwear to housewares. And the question is, why do they use it? And it comes really down to this slide right here. Most creative processes that start with ideas and end in physical products have a process that you go through. And that process gets more and more expensive to change as you get further along. Some studies suggest that it's 5 or 10 times as expensive to make a change in the next phase of a project like this than it is in the early phase. And so we'll just do a quick example. You want to design a cell phone. You've got a concept, an idea for a cell phone. You get out paper and pencil, you write down what the interface is going to look like, what the communication technologies are, how long the battery is going to last, et cetera, et cetera. Maybe you draw a diagram of this thing. The grand total amount of time that you spent is a couple of hours. The total cost is almost nothing. Okay? From there, you hire a bunch of engineers, electrical engineers, mechanical engineers. They're in CAD. They're designing all the components, making it all work together. Now you're spending real money. Changes at this point in time require coordination across large groups of people. Documents have to be updated, et cetera, et cetera. You go on to build and test. So here's where you're making prototypes that are designed to test out specific concepts that you have inside your design. If you make changes at this point, you have to go back to the other phase and get into detailed design again and redo everything, and it gets really, really expensive. If you do finally make it into manufacturing, now the scale of this thing has become extraordinary. You've hired people to manufacture this, you've designed tooling, you've created tooling, you've designed production lines, and if you change something at this point, you've probably killed the project. Okay? And so what you're trying to do with a three-dimensional printer is push all those changes earlier in the design process where the cost of those changes goes down to effectively zero. David Kelly, the founder of IDEO, probably the most famous industrial design firm in the world, describes this as failing faster to succeed sooner. And as I mentioned earlier, this basic concept is true in lots and lots and lots of disciplines. It's probably true in medicine too, although again, I don't know anything about medicine. One place I know it works is in architecture. So architects have been building models for years and years. They have the exact same problem that designers do. If they get to construction and they don't know exactly what it is they're trying to make, then they've blown their project. They've ruined their relationship with a client, and they've overrun their budget. So in this next clip, I'm going to introduce Cesar Pelli. Cesar Pelli is an American Institute of Architecture Gold Award winner and the designer of the Petronas Towers in Malaysia, and we'll hear what he thinks about 3D printing and how he uses it.
For me, seeing designs in 3 dimensions is essential to fully understand them, develop them. The actual 3-dimensional thing that I can see with my binocular eyes allows me to understand relationships that I can miss very easily in a drawing. What the 3D printing has allowed is that we see highly refined forms that are executed in high precision.
You heard him say he can understand relationships that he would miss in a drawing. Well, if you miss it in a drawing and you go to construction, your project is a mess, okay? And so that's how he used a 3D printer. Eventually, 3D printers got out of the hands of engineers and architects and fell into some more creative groups, quite frankly. The first of those is students. And as you know, students are pretty notorious for not kind of staying within the lines, not following the rules. And they said, well, if the real problem is that manufacturing is so expensive and all that tooling stuff, why don't we just skip that? So some students at Norwich University were competing in an underwater autonomous vehicle competition, one of those remote control submarines that you see floating around on the Titanic and stuff. And they said, why don't we just design for what a 3D printer does? We're just going to make the actual parts that go on the robot. So they printed engine housings, they printed drive components, and actually put it on the robot that went into the water. Saved themselves months and thousands of dollars in the development of this autonomous vehicle. Pretty cool. Another group that has gotten a kick out of our 3D printers is artists and entertainers. Specifically, some people at Pixar have done some pretty cool things with the technology. They were actually early adopters, love the color used to make maquettes and things. I'll let them explain this next one.
Pixar's Alex Stahl, who was on hand to help with the technical details of the show, explains how it works.
Well, the Toy Story Zoetrope is a kind of magical machine that we built. Some of our favorite Toy Story characters were animated using the same tools that we used to animate the films, but instead of being rendered out to film frames, the characters were printed out using a 3D printer as actual sculptures or maquettes. These maquettes are then arranged on an 8-foot circular disc, which spins once per second when the disc is spinning, a strobe light flashes in perfect synchronization with the spinning of the disc, and the flashing of the light captures the motion of each individual step in the characters, and your brain sequences those together so it looks as if the actual models are moving.
So again, another pretty creative use of a 3D printer, a lot better than using it as a replicator, that's for sure. Now, you say to yourself, well, we're at a medical conference. Maybe you could tell me something relevant to me, and I'm going to try to do that. Again, full disclosure, I know nothing about medicine. So I thought I'd hire an expert. I think in general there are three ways that 3D printers are used in medicine. The first is to be convincing, to have a conversation with a patient or another doctor that is at a deep level and is convincing to that individual. And so I thought to myself, well, who's convincing to me? You know, I'm kind of a consumer of healthcare, not a provider, and I came up with Dr. Oz. And Dr. Oz, I thought, he was interviewed in a magazine recently, and they asked him, so why do you use those goofy props in your television show? Now, I have to tell you, I'm a little offended by the characterization of 3D models as goofy props. But I thought his answer was really interesting. And when you read it, it's essentially an extension of the idea that a picture is worth 1,000 words. A color three-dimensional print can be worth 1,000 pictures if you're in a communication with someone, especially when you've got someone who's very knowledgeable communicating with someone who may not be so knowledgeable. Dr. Oz took it one step further, talking about showing people constipated poop and things like that. You'd be happy to know we did not 3D print any poop for the purpose of this presentation. Another thing that you can use a three-dimensional printer for is to be sure. A lot like in engineering and architecture, if you don't get the outcomes that you want in healthcare, then you're going to have real problems. And so you want to make sure that what you are trying to accomplish is what you actually accomplish in healthcare, and it's very, very important there as well. So interestingly, Loughborough University, Dr. Russell Harris, is using 3D prints to reproduce sinus cavities so that instead of students having to practice on cadavers, which is very expensive and frankly a limited form of training in terms of the availability, they can practice over and over again. It turns out that the 3D prints themselves actually feel and look a lot like real sinus cavities. And so students who are practicing on them get a really, really realistic feel, both to the hand and to the eye, of what they would be dealing with when they actually work on a patient. Another interesting example, I have no idea what that word is, but it looks like a hip bone to me. It sounds to me, and again, I have no expertise on this topic, that if you're doing a reconstruction of a badly fractured bone like this, that the standard practice would be to open that person up and then kind of fit these fixtures onto the bone. In this particular case, they 3D printed the bones, did all the fixture molding ahead of time to make sure that everything was going to be fine, and then opened the patient up. By doing so, Dr. Brown at the University of New Mexico says that he saved 2 hours of time on the OR and was able to use incisions that were only 4 inches long instead of 12 inches long. Now, as the person who would be the incisee in this particular scenario, I would appreciate that. So I'm happy that he's working on that. There are also some very creative uses of 3D printers in the medical field. The first of which is this one here. Dr. Jake Berlet at McGill University up in Canada is direct printing bioceramic implants with spatially localized angiogenic factors. If any of you know what that is, then I'd like to talk to you afterwards, because I have no clue what that means. He did actually show me some pictures later. And what it basically means is that he took and created bone tissue scaffolds on the 3D printer. That was the powder that he used. And instead of using just a regular binder, he used angiogenic factors, growth factors. And in doing so, he encouraged vascular growth, cell growth in specific areas at a rate that was much, much higher than places that didn't. And so he's able to vascularize this bone scaffold in ways that weren't possible when he didn't use 3D printing to kind of put the growth factors in place. Pretty cool. Terry Yu at the National Institute of Health, again using words that I don't really understand very well. Basically what he's doing is he put an additive into the 3D printing binder that affects Xray attenuation. And so if you put more of this additive in, it looks more like bone. If you put less in, then the resulting phantom looks a lot like air. And here's kind of the distribution of effects that he was able to create. And by doing so, what he can do is he can create phantoms that are ground truth that can be used for assessing whether or not a particular scanner or a particular algorithm is good for diagnosing a certain disease progression or things like that. Now, interestingly, to demonstrate this particular science, instead of 3D printing a tumor or something along those lines, he chose to 3D print Elvis. And so I had heard that Elvis had left the building. I didn't know that he had now taken up residence in a CT scanner, but apparently he has. So that's medicine. What does that mean? We take all that together, what does that mean? At the end of the day, it means absolutely nothing. It means absolutely nothing. And the reason it means nothing is because of the 6 billion people on the planet, less than 1 million have any reasonable access to a three-dimensional printer. If they don't have the data, they don't have a printer, they've never heard of the technology, et cetera, et cetera. And so the creative power that 3D printers have is in the hands of so few people that it's not really meaningful yet. And so I'd like to share with you just a few things about why I think that's going to change. How's the future going to affect what you can make? First, we'll talk about input. I'll talk while this is going. This is a new camera technology from a company called Litro. And if you look where the cursor is at, the image is refocusing. So a typical camera captures light intensity and captures light color. This camera captures intensity and color and also direction. And so they can focus the camera after the image has actually been taken. Now, why do I care about that for 3D printing? If you combine that capability with some fancy math, that's actually a three-dimensional photograph. You could take a picture of anything and have a three-dimensional image of that you could take into CAD software and do anything you wanted with. And that technology will be consumer technology, in 5 years, within 5 years. Another challenge with 3D technology is the CAD software. I'm guessing nobody here has a seat of CAD on their table. Right, of course not. Very few people do. It's really interesting. CAD right now probably costs $3,000 a pop. If you don't have a year worth of training, then you're not going to be able to make anything interesting out of it. But that's going to change. In fact, it already has changed. This is a technology called 123D Sculpt. As you can see, it's an iPad application. You can get it on your iPad. It's free. My 8-year-old can drive this. She can make really, really interesting three-dimensional content. She's an 8-year-old, okay? This is completely brand new, and 5 years ago, people would have just absolutely shaken their head because the processing power and the interface technology didn't exist. You can change the shapes, you can do color, you can put images on the top of it. It's a pretty extraordinary advance in terms of what people can create using a computer, an iPad, et cetera. Finally, the hardware has to change, right? And the first thing everybody says is, well, it's got to be cheaper. If a printer costs $15,000 or $50,000, then I can't buy one. And so you need cheap ones. And the short answer is that there are cheap ones. There's lots of cheap ones, to be honest with you. And that really hasn't changed much, to be honest with you, because cheap 3D printers produce cheap 3D outputs. What's really going to get interesting in 3D printing, right now the bottleneck for us is the printhead itself. Everything that we put down as a binder has to go through an HP11 printhead, and there's not that many things that you can put through an HP11 printhead. But that won't be the case forever. So just like in telecommunications, it used to be that last mile, that line to your house, the copper pair, was limiting your ability to get data, and now that's been replaced by cable and Fios and things like that. The same thing is going to happen in 3D printing. And in a few years, we'll be able to put down material combinations that we can't even dream about today. And when we do that, that's going to unleash an entirely new level of creativity and applications in medicine and beyond. So what would you make if you could make anything? Again, it's not up to me, it's up to you. And I hope that you'll look at it, see whether there's anything fun that you can do with it. There's a lot more content actually in here. We can't do everything in 20 minutes. If you are interested, this presentation is on Prezi.com. You can just search for Connected Health 3D Printing, and you can explore for yourself some of the fun things going on in 3D printing. I thank you for your time. Enjoy the rest of the conference.